Page 144, continuing our discussion, lesson 2.9, which is linear equations, y equals mx plus b. Once again, a quick recap. Y equals mx plus b. M represents the slope of the line. The plus b part represents the y-intercept. And as we talked about previously, if it has a minus something, you'll want to add the opposite maybe so you can see better what your y-intercept is. So if you look at the do you know how number 4, Chrissy says the equation of the line shown is y equals 1/2 x minus 5. George says the equation is negative 1/2 x plus 5. Which student is correct, and explain? So just looking at this, looking at their equations, looking at the line, very quickly looking at the line, we should be able to see this as a negative slope. So negative slope, Chrissy's got the slope being 1/2. George has the slope being negative 1/2. So George would have to be correct just by the fact of the line having a negative slope. Okay? If they both would have had negative slopes in their equation, we would have to go further, investigate a little further. We could look at their y-intercept of the graph. For Chrissy's, it's subtracting, so if you want to add the opposite. Chrissy's saying that the y-intercept is negative 5. George is saying the y-intercept is 5. And looking at the graph, the y-intercept is 5. So that's another way we could tell that. Potentially, if they gave you two really close to being correct answers, let's say they gave you that the y-intercept was 5 on both equations, and their slopes were both negative, you would actually then have to go one step further and exactly figure out what is the slope of the line. Okay, so this one, remember, slopes change in y over change in x. So this one we could say we'd go down 1 and over 2. So the slope here is negative 1/2, and then it'd just be a matter of looking at, you know, who has an equation, slope is negative 1/2, and the y-intercept is 5, and again, that would be George. Okay, but again, for this problem with the answers that these two people came up with, automatically George is the only one that even has a negative slope for his answer, so we know George would be correct here. Number 5, Farah wants to rent a tent for an outdoor celebration. Cost of the tent is $500 per hour plus an additional $100 setup fee. Draw a line to show the relationship between the number of hours the tent is rented, X, and the total cost of the tent, Y. Alright, so what we can do is think about some things that we've already talked about. One thing we've talked about, so we've got this equation y equals mx plus b. We talked about a lesson with the y-intercept, and we kind of talked about the y-intercept being like a starting value or an initial value. Okay? A starting value or initial value in this case is going to refer to that setup fee. So I know this doesn't seem like this makes sense at all, but if you think about it, if you have a $100 setup fee, you could actually not have the tent for any hours, 0 hours, and it would be $100. Okay? And that might seem like that doesn't even make sense. Well, the idea, I guess, is that they charge this setup fee, and then, you know, I guess potentially if somebody would have signed a contract and said they were getting this tent, and then the people set up the tent, and then people were like, oh, never mind, decided I didn't need it. Well, that's still going to cost you $100, right? They're not just going to say, oh, okay, that's all right. They took some time and they got it set up, so $100 even by you not using it at that point. Okay, so that $100 setup fee, anytime if you see a setup fee or initial fee, something like that, that's going to be your y-intercept. And then it's $500 per hour. Okay, if you look at your y-axis, x-axis, we have costs in dollars and we have hours. So dollars per hour, that would be like our unit rate, that would be like our slope that we've been talking about. $500 per hour. So $500 times x is our number of hours plus 100. Okay, that would be our equation here. And that actually is going to part B. Okay, part B is actually asking what the equation is. So a different way you guys could potentially do this, rather than figuring it out that way, you could maybe just graph some points here instead. So you could say, well, setup fee is $100, so 0, 100, and then if I rent it, it's $500 an hour. So we have the setup fee of $100 plus $500. That's $600 for 1 hour. 1 hour, $600. Okay, it's pretty expensive. Okay, so that could be another point. And you can see we can't really even get another point on the graph here, right? Because we're going to be going up another $500. So that'd be $1,100 for 2 hours. I'm way off the chart here at that point. Okay, understand we can't rent it for negative hours, and we can't have a negative cost. They're not going to pay us to rent the tent. So we would just stay in the first quadrant. We could continue past that last point, put an arrow on the end, and that's what our graph would look like. Okay, and again, technically you guys could potentially graph this first, and then from your graph you could come up with the equation. You could say, okay, my y-intercept's 100. Okay, I go up 500 and over 1. My slope is 500. To me, if you guys get good at looking at the information they give you and just coming up with that equation first before you do the graph, to me that might be a better way long term for you guys to work these problems out. Workbook page 37, number 3. Danny is opening a savings account with an initial deposit of $45. And he saves $3 per day. And they want us to draw a line that shows the relationship between the number of days X and the total amount in his account Y. Alright, so they're wanting us to draw the line, and then on part B they're asking for what the equation is. Again, to me, if you get good at just looking at the information and coming up with the equation, it's probably going to be a good way for you guys to go along on these problems. Alright, so 2 things we need for our equation. We need to know what the slope is. We need to know what the y-intercept. Remember, the y-intercept, generally it's going to be like a starting value, an initial fee, something for starting out. So that might give you a hint as to what's going to happen on this problem. So at this point, basically the 2 numbers they're giving you, one is going to be the slope and one's going to be the y-intercept. It's not always going to be that simple, but that's what it is at this point anyway. So if you think about it, like I said earlier, y-intercept's going to be like a starting value. So in this case, we have an initial deposit of $45. Basically means they're starting with $45 in their account. And then saving $3 per day. $3 per day, see how that's like a unit rate or rate of change or slope that we've been talking about. So that's going to be your slope on this problem. So $3 per day. So $3 times X, which is our number of days, $3 times the number of days we saved for, plus the $45 that we had to start with, is going to tell us how much money we're going to have in this account. Again, that actually is the answer to part B for what the equation is. So I'm kind of doing it backwards of what they're showing, but that's okay as long as we take care of both of these. And then the other part is graphing this. So graphing it, they told you that X is the number of days. So if you want to put number of days or just days, and then the y-axis is going to be the account balance in dollars. And make sure you put dollars there. If you just say account balance, we really don't know what kind of monetary system that you're using. All right. For the days, we're probably okay to go by ones. For the account balance, what you might want to do before you pick numbers for your account balance, you might want to look at some different values here. So we've talked about before, if there's no fractions in the equation, we can use the numbers 0, 1, and 2 for our X values. Those are nice numbers that will work well for you. All right, again, if you want to use a middle column where you can work this out, you can, or if you want to work it over to the side, you can. So with a 0 in place of X, 3 times 0 is 0, plus 45 is 45. That's our y-intercept. 3 times 1 is 3, and then 3 plus 45 is 48. I don't have a whole lot of room on my screen to show you all this stuff, but you may want to work that to the side somewhere just to be safe. If we put a 2 in, 3 times 2 is 6, plus 45 is 51. Okay, so this tells me my coordinates of my points. 0, 45, 148, and 251 would be 3 points that would be on this line. So like I said, the reason I did that first is because I want to make sure I'm not going to run out of room to even graph these points. Okay, so for example, you know, obviously if you go by ones, no chance it's going to fit on the graph. You go by fives, actually it's probably not going to fit on the graph either. All right, so what you might want to do here, it's not going to be as easy to graph your points, but you might actually want to go by tens. Okay, another option you have would be that you could do a little break. Okay, you could, you know, on your y-axis, you could do a little squiggly deal there. It's called a break in the graph, and skip over numbers basically. And then you could actually, it's kind of seems cheating in a way, but you could actually then start at 45 and go by threes. Okay. And I can show you that in a minute. Let's imagine that we chose to go by tens and see what that would look like. Okay, so at 0 we would be at 45. At 1 we were at 48. And at 2 we're at 51. Okay, so graph something like this. Again, you may want to use a ruler or edge of a piece of paper to draw a nice straight line there. Okay, so that could be what your graph looks like. Like I said, your other option would be to have a break on your y-axis, and you could actually go start at 45. If you have a break, you can actually keep just going by, you know, whatever number you start going by at that point. So if I notice my slope is 3, I'm going to go by threes if I do that. Okay, you can't start going by 5s or 10s and then all of a sudden change it to going by 3s. But if we start out with a break, then we can just go by 3s. So that would mean, you know, 0, 45, 148, and 251. Okay, it's kind of like zooming in on that part of the graph is basically what happens. So if you'll notice those graphs, they don't really look like they're doing the same thing, do they? Okay, the slopes look different totally, but it's just because we're kind of zoomed in on that second graph there. Number 4 is a similar type problem. Linnea is renting a bike. It costs $4.50 an hour plus a $5 deposit. So draw a line to show the relationship between the number of hours a bike is rented, X, and the total cost of renting a bike, Y. So they want us to draw the line there. In order to draw the line, Part B actually asks for the equation, but again, technically with the words they gave you, you guys should be able to come up with an equation for this line. Slope and the y-intercept. So the slope is how much it's changing. So in this case, $4.50 per hour. That's our rate of change or our slope. So it's $4.50 per hour times how many hours we rent it, plus that $5 deposit. Okay, that's like our initial fee type deal that we've been talking about. So this would be actually our equation, and then we could pick some points here. If you put a 0 in for X, 450 times 0 is 0, plus 5 is 5. This one has a decimal in it, so you could put 1, but it's going to have a decimal if you go to graph that point. So I'm just going to skip over to 2. 450 times 2, that'd be $9. 9 plus 5 is 14. And then I'm going to skip to another even number, 4. So 450 times 4, that would be 16, 18. 18 plus 5 would be 23. So those would be some nice points that I could graph. Remember, when you go to graph this, you want to label the x-axis and the y-axis. So this would be x-axis is our time in hours, and the y-axis is the total cost in dollars. Once again, the costs are getting pretty big here, so you don't want to go by ones or you're not going to have enough room on your graph. If you wanted to, you could try to go by potentially 2s. I'm not sure if 2s is going to be not enough to get everything to fit. So you might want to go by 3s or 4s. I'm just going to go by 4s, so we can get our points all to fit here. So for 0, it was 5. So just a little above the 4 here. Again, we're going by 4s, so 2 hours was 14, so that'll be right between the 12 and the 16. And then 4 hours is 23, so that'll be just below the 24 up there. Okay, and again, these points should be lining up with each other when you go to graph this. Should make a straight line. Okay, and again, part B, the equation, we already talked about that part. So number 5, the line models a recipe for chicken pie. The recipe calls for 14 ounces of chicken for the first 4 people, and then 6 ounces of chicken for each additional person. Write an equation for the line in slope-intercept form, where x is the number of additional people and y is the total number of ounces. Alright, so a key word there, x is the number of additional people. Alright, so they're wanting us to write an equation for this. So technically you could look at the graph here. We'll talk about that. Actually, with the information they gave you, you could figure out some of this stuff on your own. So we've got an 8 and a 16, and then we've got a line in between here. So the difference between 8 and 16 is 8. So half of 8 is 4. So if we go 8 plus 4 would be 12, would be that point in between there. Okay. If you'll notice this point, that y-intercept looks to be halfway between the 12 and the 16, which would be 14. And actually, I don't even have to do all that work because they told me that. This is the information right here. 14 ounces of chicken for the first 4 people. Okay? On the x-axis, notice that's the number of additional people. That's after our first 4 people. Then we're just putting 6 ounces of chicken per person. Okay? So if I'm writing my equation, again, y equals mx plus b. Alright, I know that y-intercept is 14. That's our initial value, our starting value again. Okay? And then the only other question is, what is our slope? So the slope, remember, slope is like our rate of change. We've got here, it's 6 ounces, additional 6 ounces of chicken for each additional person. So 6 ounces per person after we get past those first 4 people. Okay, we got the big eaters there, I guess, the first 4 people. So 6 would be our slope then. And again, if you didn't catch that from there, you could look at your graph. Remember we talked about this point was at 14, 0, 14. Find another nice point, looks like right here, would be at 120. Okay, so 0, 14 to 120, go from 14 to 20 would be going up 6. Okay, change in y over change in x. So I'd be going up 6, and then we went over from 0 to 1 would be going over 1. And 6 over 1, 6 divided by 1 is 6. So that would be another way to really, you got 2 different options, either by the words they gave you or by the graph. Again, if you can get to a point where you can get the information from the words, that is good to be able to do that, because technically they don't have to give us both of these. They don't have to give you the words and the graph. They could give you one or the other, and you could figure out what the equation is based off of that. So part B, if you have 26 ounces of chicken, how many people can you feed? A couple different ways that we could figure this out. So 2 different ways that you guys could do this problem. One way you could work this out would be to use your equation that we came up with. And remember, the amount of chicken is the y. So what we could actually do is put 26 in place of y, and then you could solve the equation. The nice thing about doing it this way is we don't have to worry if our graph's perfect. We don't have to worry if the answer didn't come out evenly. Okay, we can figure out with the numbers exactly what it's going to be and not have to worry about all those variables of, you know, did I draw my line perfectly straight, or did the answer come out exactly even. So you guys know, to solve this equation, they're adding 14, you would need to subtract 14. And then they're multiplying by 6, you would need to divide by 6. Okay? When you divide by 6, 12 divided by 6 is 2. Alright, now we've done a little bit of work here. 2 is not our answer. What we have to remember, this was the additional people that this would feed after the first 4. Okay, so we had some 4 very hungry people, and then 2 normally hungry people, I guess. So 4 plus 2 means we could actually feed 6 people altogether. Okay, now that's what's called solving it algebraically. That's working it out by hand. The other option we could do is look at the graph. Another option we could do is try to look at our graph. Again, this depends on the graph being perfectly straight and us being to exactly tell where our point is. Also, it depends on the answer coming out exactly even. This problem, it actually works out pretty well though. 24 to 32 is a difference of 8 once again, so half of 8 is 4. So if we add 4 to 24 would be 28. Remember, we wanted to get for 26 ounces. So 26 ounces would be halfway between 24 and 28. And if you look, 26 looks to be right at 2. So that's for 2 people. Again, we had the 4 hungry people at the beginning, so add the 4 to the 2 that we got, and that would be 6 people altogether. Number 7, they want us to write an equation for each line in slope-intercept form. So to do that, remember it's like y equals mx plus b. M is our slope and b is our y-intercept. So for line 1, we can look, see what our y-intercept is, and if you want you can go from that point, find another point on the line. Actually there's one right here at the edge if you want to use that. Looks like they're going by ones, so remember slopes change in y over change in x. So from the y-intercept we're going down 2, that'd be like -2 over 1. So -2 over 1 would be the same as -2 for our slope. Okay, so m is our slope, so y equals -2x plus our y-intercept, which was at -5, right above the -6 here, so -5. So y equals -2x plus -5, or that could be written as y equals -2x minus 5. Actually, either one of those would be okay. Line 2 also looks like it has a negative slope. Find your y-intercept here, and then find another point on the graph. So it looks like if we go down 3 and over 1 would get us to another point on the graph. So slope would be -3. So m is our slope, so y equals -3x, and then the y-intercept would be at 3. So y equals -3x plus 3. Again, hard to see with everything I've written here, but there was 3 was our y-intercept to start with. Okay, so this gives you an idea how to analyze linear equations with slope-intercept form, y equals mx plus b.